Howdy folks, in this problem we're asked to compute a surface integral over the function y, where our surface S is the plane that lies in the first quadrant. So the first thing we should do is we should sketch our region. So I've sketched the region. You can see I included the intercepts. So let's look into actually computing the surface integral now. So we've got the surface integral over the function y. And what can we do? Well, this isn't a very practical way to compute the surface integral, but suppose we have some r of uv is a parameterization. Then we can take this surface integral and think of it instead as just a standard double integral over r, where that's the region that our parameterization is over. We could write y as a function of r, and then we multiply that by the magnitude of partial r partial u crossed with partial r partial v dA. So let's go ahead and come up with the parameterization and then compute the necessary components. In this case, I'm going to think of the space for my parameterization as coming from the base of our xy plane and then projecting that surface right there, or that region right there, up into the surface. So for this reason, I'm going to use the variables x and y for my parameterization as opposed to u and v. If you'd like to replace all these subsequent x's and y's with u's and v's, you're welcome to do so. So we'll give our parameterization r of x, y as a standard parameterization where I simply let the x coordinate be x, the y coordinate be y, and then I need to be able to describe the third component in terms of the first two. But luckily we're told that we're on this plane. If I solve that equation for z, we get so we can parameterize that third coordinate as just 6 minus 3x minus 2y. Of course, the parameterization is no good unless we state the domain for it. And in this case, because we're looking at that black region in the xy plane, careful folks, there's a bit of rotation there. So I can go ahead and give the domain for this parameterization as x ranging between 0 and 2. And then I need to be careful. My y values are going to range between 0 and, well, the y values will stop when they hit this line here on the right hand side. So we need to give the equation of that line. This boundary line right here has the equation y is equal to negative 3/2 x plus 3, and you can check that. So that's going to be the upper limit for the y in our parameterization. So now we've got our parameterization, and we've got, this would be our region R here. We're well on our way to being able to evaluate this. Perhaps the best component is to compute this piece right here. So let's first state that partial r partial x would be the vector 1, 0, negative 3, whereas the partial r with respect to y would be the vector 0, 1, minus 2. I'm going to take the cross product of these two vectors. I'll abbreviate this as r sub u, I should say r sub x cross r sub y. So that's I, j, k, and then I fill in the rows 1, 0, negative 3, 0, 1, negative 2, and I'll compute the cross product. So now that I've computed that cross product, we need its magnitude. So that means the magnitude of partial r partial x crossed with partial r partial y is the square root of the component function squared. In this case, the component functions are just constants, making this a little bit easier. So now we're ready to tackle the surface integral completely. So here was our surface integral. And what we do is we transform this into the UV space, which in this case I'm still labeling as x and y. And I did that only because I'm using the natural parameterization there. If you'd rather use u and v, you're welcome to do so. We said the x components. Well, let's go ahead and first write. So we said we're going to integrate this between x equals 0, x equals 2, y equals 0, y equals minus 3 halves x plus 3, and then y, because I replace y with y in the parameterization, times the square root of 14 dy dx. So solving this, so folks, we ended up with the value of that surface integral being 3 times the square root of 14. Let me know if you have any questions on this.